Math Analyzers. Welcome to your Chapter 7 Lesson 4 notes. We are finally getting into logs and what logarithms are. So, a logarithm is another way of expressing an exponent. Okay? We're changing our exponent so that we can start expressing exponents that aren't just integers and fractions. Okay, that's where we're looking into. So we can change our regular exponential form of having a base raised to a power equaling a value into logarithmic form. Your log has its base, same as this base. The value is right here, and the answer is the exponent. So it's log base 2 to 8 equals 3. Say that, practice that. Log base 2 to 8 equals 3 so that you can correctly read a log. Okay? Now, of course, we need to make sure that our value is a positive constant, right? So a number, a value. It's not our x. Okay? Or b, excuse me, is our positive constant, and again, not equal to 0 because that wouldn't make, or excuse me, not equal to 1 because that wouldn't make any sense. Log base 1, well, everything is itself then. That doesn't make sense. Everything is going to be 1 then. All right. So, like I said, a few restrictions put into place. We don't have a base of 1, so that's this guy right here, and that's just because every single time, right, this wouldn't be able to happen. X to 1 to whatever power is going to be 1. So you're never going to be able to do anything like this. So we just don't bother with base 1 as something that we put in logarithmic form. Okay. Also, we need those a and b to be constant, or excuse me, to be greater than 0. So your base needs to be a value that's bigger than 0. And your a value, meaning your answer right here, needs to be a value that's bigger than 0. Okay, and that's just stuff that kind of will intuitively make sense as we get into the logs. Okay, you can have a negative. You can have a negative somewhere, and I'll show you where as we get in. Okay, but typically this is what we look at. So no negative right here, right? And then no negative base. So notice C, this answer over here, that could still be negative. I'll show you that when we get in. Really, we're going to start with just converting back and forth because that's where the real power in these lie. If you don't understand that this whole thing is the same as an exponent, that's really where you'll get bogged down. Okay, so that's the very first thing we want to do is just convert logs back into exponential form and convert some pieces of exponents into logarithmic form. All right, let's just get that part down pat together. So when I see log base 3 to 27 equals 3, this is saying convert this back into exponential form, right? So your base is 3, your exponent is your answer in the log, and this 3 to the third power, 3 times 3 times 3, is 27. Okay. 4 to the negative third power is 1 over 64. So see how I said you can have the exponent be negative like this? And then this answer right here is, of course, the flipped fraction. And then we're raising to the third power. So this makes sense with what we were looking at before. Now we've just seen it in logarithmic form. 10 to the what power equals 1,000? 10 times 10 times 10, or 10 cubed is equal to 1,000. Makes sense. 3 to the what power equals 1? Well, anything to the 0 power equals 1, including 3. So you can have 1 here, right? You just can't have one here. All right, 1/2 to the negative third. So 1/2 raised to the negative third equals 8. Yep, makes sense. Flip the fraction upside down. 2 times 2 times 2 is 8. Lastly, 100 raised to the 1/2 power equals 10. Excuse me, that's 100. My bad. 100 raised to the 1/2 power equals 10. Well, that makes sense because the 1/2 power is really the square root. Those are interchangeable. But that's what we recall from lesson 1 when we reviewed all of our exponents pieces. Okay, that's the first thing you really want to get down. All right, get it in your head that convert those logs into exponents, and the reverse is true. Convert those exponents back into logs. That's the next thing we're going to do. Okay, is we're going to take our exponents and we're going to write them in logarithmic form. Make sure you understand these. Now we're going to apply that the other way. So now we're going to take each exponential equation and rewrite it as a logarithmic equation instead. Okay? So the base is 7. So log base 7. The answer is 2,401. So to the 2,401 equals 4, the exponent. Log base 6 to the 1/36 is -2, equals -2. The exponent is what's on the other side of the equal sign. This one is just written backwards, right? The base is 12, so log base 12 to 144 equals 2. 12 to the what power equals 144. If I didn't have this 2 over here, that's what this is asking. 12 to what power equals 144? 49 to the 1/2 power equals 7. Okay, so it's log base 49 to the 7 equals 1/2. And again, remember that the square root of 49 equals 7, and a square root, a regular square root symbol, is just 1/2 as an exponent. Okay, log base 1/3, so I'll put that in parentheses just to make sure you recognize that whole thing is the base, to the 9, because that's the answer, equals your exponent, -2. Last but certainly not least, remember this is written backwards. The base is 4, so log base 4 to 1 equals 0, because anything to the 0 power is 1. Okay. Obviously, I'll insert a pause, but stop right here and take those in. Just converting back and forth. Logs are exponents, exponents are logs. Flip them back and forth, okay? Understand where each piece lies so that we can then get deeper into logs together, okay? There are 2 types of logs that are very common, intuitive, normal when we talk about logs as a general rule, okay? Those would be the common log and the natural log, all right? And both of these are the log buttons on your calculator that you see pretty regularly. Obviously, I have that calculator there, but I'd like to just kind of put this in here to show you. This is log base 10. That's what's assumed. This is ln, or the natural log, which is log base e. E is a constant number like pi, and I'll explain that in a second. These are the 2 most used log forms, log base 10 and log base e. They are so common that they have their own notation, which would be just writing log, not writing log base 10, and just writing ln, not writing log base e. But notice that's what it's equal to. So if you struggle when you just see log or you just see ln, rewrite it to have the bases so you remember what that is. Okay. Now, what the heck is E, right? What's E? E is a constant known as Euler's number. Euler. Guy named the number after himself because he was kind of the leader in solidifying this as a constant value. Pi is a constant value, right? That is a non-repeating, non-terminating decimal. So is E. E is an irrational number. But it turns out that there's these really frequent applications in logs and with exponents that go towards E. A lot of times used in interest formulas, okay, where we use E a lot. I'll have a video that'll be like a little bit of a supplement for you guys about E a little bit further, but it's very fascinating that numbers like pi and E are irrational and yet occur naturally in the regular types of applications that we use mathematics to describe the world around us. It's very fascinating to me that irrational numbers would just naturally be in existence. Feels like we make those up, right? But they naturally occur. Everything isn't just perfect all the time, even though math is just so close to it, right? Math is close to the perfect language. Yes, this is the video that I'll be sharing with you because obviously you don't have that URL right this moment. Okay. If you're trying to get to 1 as your exponent, right? It would be e to the 2 pi I. So it's even got imaginary in it, right? And pi. I mean, we're just going all out in e. That would be ln of 1. So ln of 1 is equal to that, okay? 2 pi I. I'll talk about it. Don't worry. Don't panic. LN doesn't appear a lot in what we do at this level, okay? Let's actually evaluate some expressions. So notice these are not logarithmic equations because I do not know the answer on the other side already. So this is not, the directions here are not convert. The directions here are, what is the exponent on this base that gives me this answer? Okay, that's what the directions here are asking when they ask you to evaluate. So the question you want to be asking yourself is 4 to the what power equals 4,096. Okay, and so this is, to me, where your graphing calculator can come in handy in a couple of ways. All right, so let's take 4 and raise it to the second power just to kind of get ourselves going. I know that 4 squared is 16, but again, just getting you going into how you can think of, okay, that would be the number right here. And that number right here that I want is 4,096, right? So 4 cubed, of course, is 64. And then I start to get into, okay, well, what's 4 to the 4th, right? Oh, okay, 256. So let's keep going. 4 to the 5th power. Let's see how that goes. 1,024, okay? Now 4 to the 6th power, aha, there we are, right? So that's where I want you to see the answer here is 6. 4 to the 6th power is 4,096. 2 to the what power is 32. That's what you're asking for, right? You might not know this one off the top of your head. So let me just give you a quick reminder of our 2's. 2 squared is 4. 2 cubed is 8. 2 to the 4th power is 16. 2 to the 5th power is, oops, hello. Hey, back. 2 to the 5th power is 32. Okay, just in case you don't have those ones memorized. Oops, I'm writing my answers in red. There we go. 2 answers here. ln of 1 is either 2 pi I, which we talked about above, or 0. either of those. Because really, if you're getting 1 here, that's anything to the 0 power, right? Either of those, I would go with the easier one. If you're unsure, here's what's great about the ln when it appears. Just press it on your graphing calculator and put in your number. Your graphing calculator is going to tell you 0, so that's what I would go with writing on your paper. The other equivalent is 2 pi I. It's going to get you to 1. 4 to the what power is 1/16? Well, I know 4 squared is 16, so if I'm flipped in the fraction, that's got to be a -2. 25 to the what power is 5? Well, if I take the square root of 25, I get 5, right? What's the square root in an exponent? 1/2. Just memorize that. Okay, just memorize that conversion. You're going to see it a lot. 2 to the what power is 1/16? Well, I know, and it's right on my screen here, 2 to the 4th power is 16. So 2 to the -4th power is 1/16. And if you're unsure and you just want to be sure about it, 2 to the -4 is, of course, going to be given you in decimal form, but press math, enter, enter, and it converts that decimal into your fraction of 1/16. So that's how you can check your answers. So right now, your homework is just convert back and forth and evaluate. That's it. The 3 exercises we did, that's our beginning of logs. And we're going slowly into this. So you take your time to really solidify to yourself that an exponent can be written as a log and a log can be written as an exponent, and go back and forth. And that is how we want to begin. When you evaluate a log, you are asking what the base to what power is this number in my log. Give it a try, guys. I think you got this. But again, if you don't, I am here to help you. Okay? So please ask me if you need anything when it comes to the logs. All right, I'll be seeing you guys very soon. Have fun.